Integrating standard functions, part 4. So integrating e to the power of 2x will give us e to the power of 2x again, because that's the same as this, but we have to divide by the coefficient of x, so we have to divide by 2, and then we're going to multiply by 5 and then substitute the limits in. So we get this, substituting the limits in, 2 times when x is 7, 14, and 2 times when x is 3, 6. So that's the final answer, or we can factorize like so. And we could go even further and write this as the difference of 2 squares, and then factorize. Here we need to split this into 2 separate fractions and then simplify the indices. So into 2 separate fractions with the same common denominator. Then 2 over x cubed is 2x to the power of minus 3, and then we've got x to the power of 1 over x to the power of 3, so x to the power of minus 2. And then we integrate these terms. Okay, so I've done the integration, so I'm increasing the power by 1 and then dividing by the same new power. I was multiplying by 2. Increase this power by 1, divide by the new power. We can simplify before substituting in the limits, like so. And then the final answer, 1.76. Okay, so we're integrating minus 2 sine 5x. So there's a number of ways of doing this. We can think of it as either minus sign, so if I put a minus there, I've got to change the sign there. So minus sign will give cos, and I've got some alternatives coming next. So to begin with, I'm just going to integrate this exactly as it seems. So we've got what, minus sign will give cos. There we go. Same angle, 5x, we divide by the coefficient of x, which is 5 there. We were multiplying by 2, and you might think, what happened to the minus? But remember, we're integrating minus sine this, and that gives positive cos here. So I've dealt with the minus here already. Substitute the limits in, and then simplify. In this alternative approach, I'm going to take out the minus 2. Okay, it's just a coefficient, just the constant that we're multiplying the sine term by. I can put it on this side, like so. Now I'm integrating this. Whatever I get, the final answer after all the integration's done and you put your limits in, right at the end you multiply by minus 2. So this is positive sine. So I'm going from here to here. So integrating sine 5x gives minus cos 5x, then divide by the coefficient of x, substitute the limits in, simplify, same answer as before. I've multiplied by minus 2 right here, final step. Another alternative, instead of taking out minus 2, I could just take out the 2 and leave the minus with the sine 5x, like this. So now I'm integrating this, and it's saying minus sine. So I'm going from here to here. So I will get cosine. Again, I will do all the integration, put the limits in, and then multiply by 2 right at the end. So I've got my cosine from here. Substitute the limits in, and then right at the end, multiply the 2 in. Same answer. So we have y equals 1 over x, and we want to work out the area of this shaded region. So we're integrating 1 over x in between these limits, and the formula is this, where we get natural logs. We have to use the modulus notation this time, because we have negative values, and we can't put negative values for a log. Whenever you work out the log of anything, so log or natural log in this case, ln x, this has to be a positive value. It's one of the conditions for logs. That's 2, and that will be 5 because it's got the modulus, like so. That's the final answer, or we can use the division rule for for logs and write the final answer as ln 2/5. Example 9. So we integrate. We have to divide by the coefficient of x, which is -1, like so. Simplifying, we can just put a minus here, then substitute the limits in. Now this term and this term need careful consideration when simplifying, so let's have a look at this one first. So e to the power of minus ln 5, that's a -1 times the ln 5, which we can write like this. With the power on power rule for indices, these are just going to be multiplied. So -1 times ln 5 will give us the minus ln 5. So this is the same as this. Now in the brackets we have a function and its inverse. They will cancel to leave 5. That -1 is a power on the outside, so we get 5 to the power of -1, which is 1/5. And we can do the same for e to the power of minus ln 2. We get a half, and then substitute in the 1/5 and the half and simplify 3.3. For practice, try these questions.